Classification-aware defect ranking is a model that I developed for prioritizing defects based on a mandate to repair and the breadth of exposure. This video presents how to calculate the CDR model defect ranking score. Before we review the defect ranking score equation, let's summarize the model and review each of the factors to be considered. The overview video for the CDR model presented that it provides a way to sequence defect resolution efforts based on delivering the greatest benefit and satisfaction in the shortest time for a backlog of defects. The defect ranking score offset is determined by dividing the need to resolve by the effort to resolve, so that the most needed resolutions required the least amount of work have a higher defect ranking score within each class of defect. Here we see that the need to resolve is captured as this equation segment, and we'll discuss these variables in the upcoming slides. We'll also discuss using understanding as an inverse proxy for effort or time. Here we see the equation and the defect ranking score variables, as well as typical options that can be used to capture the variable values. Let's review each variable in the next few slides. Class is the variable used to capture the defect tier or classification. The CDR model starts by recognizing these three classes. However, the model may be used with more or fewer classes. For example, perhaps your organization doesn't distinguish between customer-reported defects and other known internal defects. The model will work with two classifications. In the examples considered in these videos, we assume that defects found by customers using the general release version of the solution should be prioritized over an internally known defect having the same reach and impact as the reported defect. Defects in higher tiers, those inherently more likely to have bad consequences if unresolved, will have a higher defect ranking score. Reach is an indication of how many users are affected by the defect. Because it is unlikely that every user or customer would use an application feature or solution capability in the same way every day, the reach of a defect is likely different day by day. To have reach be a meaningful value, establish a time period for estimation. How many users would encounter the defect during the next month, the next 3 months, the next year? Choose a time period that aligns well with your planning cadence so that the defect ranking score is meaningful at the start of each planning cycle. While the defect ranking score is determined using an equation and therefore requires numeric values, experience has shown that it is better to interact with the model using a set of options to choose from that more closely aligns with the language of the enterprise. An upcoming slide will provide a default pairing of the natural language option to a number. Impact is a measure of the consequence, like severity, of the defect. Be sure not to fuse impact with the impact radius. That would be reach. Some defects cause minor inconveniences, while others could result in data loss, security breaches, or severe functional limitations. The level of consequence, the impact, is the same for a defect that affects a single user or a large group of users. A clear understanding of every user and how they interact with the application is not always possible. Users will often use an application in ways never imagined by the product management team. To account for the possibility that there may be a variable level of confidence in choosing the correct reach and impact options, a confidence variable may be used. For ease of use, the value defaults to high level of confidence, but allows for capturing uncertainty. While there is usually pressure on teams to get all the defects fixed, some defects will have external pressure drivers, such as a need to resolve defects blocking a feature required to satisfy a new regulation, or fixing a defect in a certified workflow that jeopardizes your certification, or even a defect that has been reported by a key customer where you have negotiated a resolution timeframe. The pressure variable is used to boost the defect ranking score for defects that are getting close to a due date. Because it is hard, and perhaps unfair, to ask a team how much time they need to fix a defect, and because sizing a defect, like sizing a user story prior to planning, is also an unfair request. The CDR model uses understanding as an inverse proxy for time or effort. As data becomes available, the team will be able to find a correlation between understanding and time or effort. However, this should not be the consideration when using the CDR model. It is better to ask in a more fair question: how well do you understand the possible cause of this defect? Here you see the pairing of option text and option values. These values have been found to work well. These values provide a small overlap of defect ranking score between defect classes. This provides the opportunity to take care of some low-hanging fruit, or potentially easy fixes, from a class of defects that is normally considered to be lower priority. Putting these values to use will be shown in the video on using Excel to calculate the defect ranking score for the CDR model. We have discussed the CDR model parameters and calculating the defect ranking score to sequence defect resolution efforts to maximize the breadth of benefits and satisfaction in the shortest time for a backlog of defects. The CDR model acknowledges that there is an inherent tiering of defects, and the defect ranking score considers factors that are natural in a conversation about defects as an offset within each defect tier or class. Thank you for your interest in the CDR model and using the defect ranking score. With the overview in this video on calculating the defect ranking score, you are able to apply the CDR model. However, I encourage you to watch the video on using Excel so that it will be easier for you to get started. For more information, visit my website.